Hi, 8th grade. Welcome to lesson 6-3, Analyze Rotations. By the end of the lesson, I want you to be able to say, I can rotate a two-dimensional figure. Let's explain it. Maria boards a car at the bottom of the Ferris wheel. She rides to the top where the car stops. Maria tells her friend that she completed a fourth of the turn before the car stops. So Maria's starting here, and she ends here and says she's gone a fourth of the way around. Part A. Do you agree with Maria? Explain. No. She has gone 1/2 of the way around. How could you use angle measures to describe the change in position of the car? Well, she started here and ended here. That straight line, how many degrees is in a straight line? 180 degrees. Thinking about that, how many degrees is in a full circle? There are 360 degrees in a full circle. So if she'd gone halfway around, you divide that by 2 to get 180. Focus on math practices. How can you describe Maria's change in position when her car returns to the position when she began the ride? Well, she would have gone 4 out of 4 around, all the way around. Or we could say she went a total of 360 degrees. One feature of the new patio plan is a rectangular umbrella that can easily rotate so that the clients can enjoy either the sun or the shade. Where should the architect move the umbrella to highlight this feature for his clients? An architect rotates the umbrella 90 degrees counterclockwise. Remember a clock? Here's a clock, here's 12, here's 6, 3, 9. Clockwise is when you go around this way. Counterclockwise is when you go the opposite way. So the architect rotates the umbrella 90 degrees counterclockwise. A rotation is a transformation that turns a figure around a fixed point called the center of rotation. The angle of rotation is the number of degrees the figure rotates. A positive angle of rotation turns the figure counterclockwise. So you're always going to go counterclockwise unless they tell you not to. The umbrella has been rotated about its center. The umbrella has the same size, shape, and orientation. Okay, so if you can see, it's kind of hard to tell because the umbrella has the same shape. It's a square. But if you can see now, there's the part with the stripes is now on the right because we rotated it that way. Let's try it. The architect continues to rotate the umbrella in a counterclockwise direction until it gets in its original rotation. What is its angle of rotation? Well, if it already rotated at 90 degrees, so we've already done 90, I want to know 90 plus what equals 360, because we know 360 would get us back to the starting spot. So you could subtract 90 from both sides, and that would be an angle of rotation of 270 degrees. Convince me, how does an image compare to its pre-image after a negative 45 degree rotation? When you have a negative rotation, that means you're going to rotate 45 degrees clockwise because you're going to go backwards. And we're always going counterclockwise unless it's a negative rotation. Example 2, complete a rotation. What are the coordinates of an image of a trapezoid ABCD after a 90 degree rotation about the origin? Draw a ray from the origin to point D. Then use a protractor to draw a 90-degree angle in the counterclockwise direction. Plot point D the same distance from the origin as point D. Use the same method to wrap each vertex of trapezoid ABCD to its image and draw the trapezoid. So if we look at our original trapezoid ABCD, it has been moved 90 degrees. 90 degrees means it goes in the other quadrant. Remember, we label our quadrants 1, 2, 3, 4. I did that wrong. Back it up. 1, 2, 3, 4. That's better. So we rotate in the order that we label our quadrants. So if something starts out in quadrant 1, we know it's going to end in quadrant 2 if it's a 90-degree rotation. If we start in quadrant 1 and we end in quadrant 2, that's a 180-degree rotation. And if we start in quadrant 1, and end in quadrant 4, that's a 270-degree rotation. Okay, so each rotation, each quadrant is worth 90 degrees. So if the points are both positive, A and B are X and Y are positive in the first quadrant, what are they in the second quadrant? Well, X is negative and Y is positive, and we have to switch the X and Y values. Let's notice what they did first, and then I'll talk about the rules. So they did it with a protractor. We're not going to do that. We're just going to think about it. So they knew that A was originally here at 2, 3. And then when they plotted the rotation, it went to -3, 2. B was 4, 3 and went to -3, 4. C was 5, 1 and went to -1, 5. And D was 1, 1 and went to -1, 1. Well, thinking about the X and the Y values, the numbers all stayed the same, but they switched order. So when we rotate 90 degrees, you switch the order, and you're in the second quadrant. In the second quadrant, the X values are all going to have to be negative, and the Y values are all going to be positive. The rule when you are switching 180 degrees, so that was the 90 rule. When you're doing 180 degrees, you don't switch the order. You just make them both negative. Just think about that. In the second quadrant, both X and Y are negative. And then 270 degrees, you switch the order, and the Y value is negative, because that's what's in the fourth quadrant. Let's try it. The coordinates of the vertices of HI, J, K are H is 1/4, I is 3/2, J is -1, -4, and K is -3, -2. If quadrilateral HIJK is rotated 270 degrees about the origin, what are the vertices of the resulting image? Well, if we draw a rough sketch, I know H is 1/4, so that's here, that's H. I is 3/2. J is -1, -4. And K is -3, -2. So I want to rotate it 270 degrees. So I'm going to look at this rule of 270 degree rotation. And I know I have to take both my points and flip them and make the second one negative. So H prime, instead of 1/4, it's going to be 4/1, but I need the second one to be negative. Instead of I, it's going to be I prime. I switch the 2 in front and make the 3 negative. J prime, I get -4 in front. And I have -1 in the back, but I need to make that negative. So a negative times a negative gives me a positive. And K prime, I have -2 in front and -3 turn that positive. Okay. Describe a rotation. Describe a rotation that maps parallelogram ABCD to parallelogram A prime, B prime, C prime, D prime. Well, we start with the black one, and remember we always go counterclockwise, and it's rotated 1/4, 2/4, 3/4. If it's 3/4, that would be a 270-degree rotation. Well, if we wanted to go the other way, clockwise, that means we'd have to do 1/4, change one quadrant, that's a -90 degrees. Describe a rotation that maps FGH onto F prime, G prime, H prime. So I want F to go 1/4, 2/4. Same thing, we can try that, show that with G. I go through one quadrant, two quadrants. And H, to get there, I go through one quadrant, two quadrants. So if I'm going through 2 out of the 4 quadrants, I can multiply 2 out of 4 by 360. Or you could know that that's 1/2 of 360, which is a 180-degree rotation. Every quadrant is worth 90 degrees. Key concept. A rotation is a transformation that turns a figure about a fixed point called the center of rotation. The angle of rotation is the number of degrees the figure is rotated. The x and y coordinates change in predictable ways when rotated. So here's that general rule of thumb.